Alright, this is section 5.3. We're going to be locating rational zeros of polynomials. The first one, this has 2 steps. As you notice, we have 10 problems. There's 17 steps altogether. This first one wants us to use the rational zero theorem and list all the potential rational zeros. Alright, the way we do that is we take our polynomial and we're going to take the constant at the back, that is 75. Don't worry about the sign right now. And then we're going to take the leading coefficient. So make sure your polynomial is in order from largest to smallest power, and then we're going to take the leading coefficient, which is a 1. We're going to list all the factors of 75 and all the factors of the coefficient, and we're going to divide each number by each term. So that is everything that multiplies to give us 75 would be 1 and 75. I'll write that at the back. It's not divisible by 2. 3 and 25. And 15 and 5 looks like. And I think that's going to be the sum of our list. Okay, once we do this, 1 is the only factor of itself. So we would take each number divided by 1. And if there were other factors down here, say 4 was down here, for example, I would take each of these numbers and divide it by 4. And that would make a bigger list. Okay, but for now we only have 1 on the bottom. So that means I'm only going to end up with the list on top. And so my possible zeros are positive or negative 1, 3, 5, 15, 25, and 75. Okay. One way you can check that you have all your numbers are to break 75 down into primes. So 3 and 25. And 25 can be broken down into 5 times 5. And then so if you think about all possible combinations of 3, 5, and 5. So we already got the 1 to 75. If you do 2 5s, you get 25 and 3. So that's how we got those two. If you do 3 times 5, you get 15 and 5, which we got those. So those middle terms are the only thing that we get added. Sorry, you couldn't see that. Okay, so here's my possible rational zeros. Notice they already have the plus or minus, so all I have to do is list all the numbers, and I think you want to list them in order from smallest to largest, so it's uniform. So 1, 3, 5, 15, 25, 75. Alright, now part 2, we want to use polynomial division and quadratic formula if necessary to identify the actual zeros. Okay, so I'm going to erase this part. And what they want you to do is do by trial and error, but it could take some time. This marker is running dry. That could take some time if you were to try to do synthetic division to figure out which ones work. So x cubed minus 3x squared plus 25x minus 75. Okay, so what they want you to do, and I recommend just using the calculator and finding the right one. That out of that list we had, let's just say I want to try 5. Okay, I can try positive or negative 5 or whatnot. So I'm going to list 1, negative 3, 25, and negative 75. Okay, so I'm going to try 5, see if it works. What I want to do is get a 0 at the end, and if I get a 0, that means it divides normally. And then I'm going to find all those numbers. So this is 1, 5 times 1 is 5. Subtract, we get 2. 5 times 2 is 10. Add, we get 35, and I'm not going to get 0. Okay, so you would try that one. Doesn't work. I'll try one more just to see if we can get lucky. Let's try 3. So bring down the 1. 1 times 3 is 3. That will give me 0. 3 times 0 is 0. Add these, we get 25. And 3 times 25 is 75. Okay, and we get 0. So this one did work. Okay, and then my remaining polynomial is x squared. I don't have the middle term x, and then plus 25. So one number is 0, and then I'm going to solve this. So we would have to subtract and move 25 over. So we have x squared is equal to negative 25, and then we would take the square root of both sides. Now with x, we just end up with x. Sorry, the x squared, we end up with x, and then we can't take the square root of a negative, so it becomes imaginary, and then square root of 25 is 5, so 5i plus or minus. Got to remember that when we take the square root. So the three terms are x equals 3, and then we have positive 5i and negative 5i. Alright, so instead of guessing and checking, because you might not get so lucky to find it on the second try or the first try, it might take several times. What I recommend is pulling up the calculator, and then we're going to graph this function and just see approximately where it crosses the x-axis, and then we'll pick that one. So we're going to do x raised to the third minus 3x squared plus 25x minus 75. Alright, I'm going to graph this. And you can see, if you count those tick marks, 1, 2, 3, you can see it crosses at 3. So once you get that 1, then you can solve it, and you'll have just a basic quadratic, and then we can solve either by factoring or quadratic formula or something like that. Okay, so for this problem, we have 3 answers: 3, 5i, and negative 5i.